I gave a little bit break for bathroom break, maybe stretch break. Let's go ahead. Molecular components of translation. Okay, so now we are done with transcription. Let's go over to translation. Translation, a cell translates an mRNA message into protein with the help of transfer RNA, tRNA. So far, transcription, end product of transcription so far you learned was focused on mRNA. Okay, but tRNA, it transfers what? Amino acids into, and brings amino acids and put them together. Okay, and you will see it, how they all come together. tRNA transfers amino acids to growing polypeptides in ribosomes. Of course, the rendezvous place is ribosomes. Molecules of tRNA are not identical. Okay, so we have different tRNA for different amino acids. We have 20 different amino acids. Each carries a specific amino acids on one end. Each has an anticodon on the other end, and anticodon base pairs with a complementary codon mRNA. Last time, I don't know I talked about it or not, these three on mRNA, can you guys see this? These three on mRNA is called a codon. Remember, these three is called a codon. Now, when a tRNA comes into a picture, tRNA is going to bring amino acids attached to it, and it will match these three pairs, these three nitrogenous bases on tRNA is called anticodon. And I will show you some picture. We'll talk about it. Let's talk about it. And right here. Okay. So these three U, and I will talk about the rest of the picture. Hang on. The U is a codon, but A is anticodon. A is on tRNA. This is a tRNA. This is a tRNA. Transfer RNA, referred to as a transfer RNA. And then at one end of it, the amino acids attach. Amino acids, phenylalanine attached. Tryptophan, other amino acids, the polypeptide. Polypeptide you know from exam number 1. And this amino acid, this transfer RNA is bringing it into the ribosome. This is ribosome. This is ribosome. It's bringing in glycine. Bringing it right here. GGC is the codon. The anticodon is CCG. Do I make sense, everybody? And they have, of course, these have to follow the law of base pairing. The law of base pairing, anticodon with codon, they have to match G with C, G with C, and that's what you're going to do in the lab today, C with G. Okay, so here they are. That's what pretty much the nuts and bolts of translation. This is a summary slide of translation, but we have more to say. A tRNA molecule consists of a single RNA strand, and that only about 80 nucleotides long. So what he's saying, all of this is about 80 nucleotide, 80 nitrogenous base. Okay, and flattened into one plane to reveal its base pairing, a tRNA molecule looks like a clover leaf. So, and I'll show you some pictures here. Because of hydrogen bonds, I bolded these things that you should know. Because of hydrogen bonds, it looked like a clover leaf. tRNA actively twists and folds into a three-dimensional molecules. tRNA is roughly L-shaped in this textbook. Okay, so what am I saying? This is all hydrogen bonds right here. It looked like a clover leaf. Clover leaf, if you look at clover, is the name of a plant. If you go to grocery store, you Google it. You go to Home Depot, any nursery, you look at clover, say, I want clover. And look at the leaf of it, it has 3 leaflet. That's what tRNA look like. mRNA straight, right? mRNA straight. But tRNA look like this, look like a clover leaf. And then, of course, hydrogen bonds cause this loop looping and folding a little bit, hydrogen bonds causes those. And then, of course, in the textbook, your textbook is referring to a tRNA as a L shape. Okay, that's a tRNA L shape. The anticodon AAG, you remember from last slide, is right here. That's anticodon, anticodon. So right here, these are anticodon of tRNA. So a few things you should know about tRNA, and that's one.
Is this the first one you went over? The tRNA?
Right, yes.
Okay.
That's pretty much, well, I started a little bit, Brian. I started right here, transfer RNA. These are all write-ups. But the highlights, I bolded them for you guys. The clover leaf, 8 nucleotides. So what does that mean? 80 nucleotides. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 80.
So there's 80
Okay.
nucleotides on the transfer.
But you don't have to memorize those numbers. I
Okay.
never ask you how many nucleotides in tRNA.
Wow.
Never. Okay? But if you want to know how big it is, it's about 80 nucleotides. Okay? And then of course, those nitrogenous bases, they form hydrogen bonds, and that's what they give a fold shape.
The anticodon is always going to be that 3 to 5.
Right here, yes, always.
It's always going to be the AA. It's going to change.
It's going to be different. It's going to be changed. From, yeah. For example, in here is AAA. Here is the anticodon. The anticodon in this case is AAA. The anticodon in this case is GCU. Am I making some sense?
Yeah.
Okay. So,
From 3 to 5 for the anticodons, it will always be like 3 to 5, or it will be 5 to 3.
yeah, 3 to 5. When they go inside of the ribosomes, 3' to 5', when you go to ribosomes, it's 3' here, 5' here, 3' here, 5' here. Yes, always. It's always like that. Good. Okay. Stick ribbon model. I don't need it. You can look at it. They just show you that it rotates. That's how it is. Accurate translation requires 2 steps. Okay. So translation. The bottom line of it is 2 steps. Let's see what they are. A correct match between a tRNA, and amino acids done by enzymes amino acyl tRNA synthase. Okay, and I'll show you some picture here in a minute. The second one, a correct match between the tRNA anticodon and the mRNA, which I didn't talk about that. tRNA and anticodon and the mRNA. Flexible pairing at the third base of a codon is called wobble and allows some tRNAs to bind to more than one codon, which again we will talk about this. Here is that tyrosinyl tRNA transferase. This was a generic name for it. Amino acyl tRNA synthase, and this is tyrosine because the amino acid tyrosine is coming in here. This is the enzyme. This is tRNA. tRNA comes in here. Amino acid comes in here inside of the enzyme. This is the active site of the enzyme. What enzyme is tyrosyl tRNA synthase? So tRNA attaches to tyrosine. And specifically what type of tRNA it is a T-tyrosine tRNA. And AAU is a complementary anticodon. And then what happens with the help of ATP becomes AMP, these two are going to be put together. So protein synthesis, bottom line, is not free. You need energy for that. You need ATP for protein synthesis. Right here, ATP. And at the beginning of semester, I said ATP inside of your body is like money. It's not free. So protein synthesis, transcription was almost free. No ATP required except GTP you needed for the cap. You remember that? But right here, you need ATP to put these two together. Okay, using ATP synthase catalyzes covalent bonds. And right here, it comes out. Now this one is ready to go to ribosome. and match with mRNA. This one is ready to go to ribosome and match with mRNA. So ribosome, here we go. Ribosomes facilitate specific coupling of tRNA anticodon with mRNA codons in protein synthesis. The two ribosomal subunits, large and small, are made up of protein and ribosomal RNA, rRNA. Well, rRNA, Brian, you asked me earlier, is a RNA that goes inside of ribosome. Ribosome, you have a small unit on top and large unit on the bottom, and then rRNA goes in there and monitor the whole entire protein synthesis to some extent. Bacterial and eukaryotic ribosomes are somewhat similar but have significant differences. Some antibiotic drugs specifically target bacterial ribosomes without harming the eukaryotic cells. Right here is a ribosome. This is the large unit. This is the small unit of the ribosome, the protein molecule. This is all protein molecule. This is all protein molecules. And tRNA comes in here. There are 3 places in the ribosomes. EPA. Look like Environmental Protection Agency, but each one of them means something. E stands for exit, and the tRNA exit. The P stands for peptidyl tRNA. The peptide bond is formed right here, and then A site is for amino acyl tRNA binding site. So the amino acyl, the new RNA, comes in here. So there are 3 at a time, at one specific time, at 1 second, one specimen, let's say less than a second, at one specific time, only 3 tRNA fits into the ribosomes. Okay, so of course, when the third one comes in, the first one has to leave. So it's like assembly line. This one is leaving, this one is coming in, this one is leaving, this one is coming in, bringing amino acids and unloading it. A peptide bond is formed, and that one eventually leaves, and so on and so forth. I hope I'm making some sense. And then I think that animation will show you a better picture of it. And here is a growing. This is the This is the mRNA. I thought this is the polypeptide. This is the polypeptide right here. That's a growing polypeptide. Amino acids, amino acids, amino acid. EPA. Again, same thing. With a mRNA in there, transfer RNA, and the transfer RNA comes and leave the amino acids behind, and they leave, they go out. I hope we have a yes.
Like the tRNA and the amino acids, they combine, or they find each other. That's the first step of translation.
Right.
And then the second step of translation is when the anticodon and the mRNA codon find each other right there. But like, so it loses the protein?
The
amino acid?
Huh?
Like when it goes in and they find the match,
right.
The amino acid comes
let
out.
me go. These two have to match. A to U, A to U, A, U. You know what I'm saying?
Yeah.
They have to match. When they are matching, of course, amino acid is attached here. So it will unload the amino acid and then shifts. This one goes here. Okay? And then this one comes here. See, this one is not attached to that amino acid. This amino acid is not attached to the amino acid. Am I making some sense? So this one, like assembly line, comes here. This tRNA. This tRNA comes
each
here.
codon has its own amino acids, right?
Huh?
Each codon has their own amino
Right.
acids.
This is, well, not the codon, the anticodon. The anticodon, this is anticodon, this is codon. Codon, anticodon. So when that tRNA comes in here, then it shifts, goes to the P side, and then from A side goes to P side, and then at P side, this amino acid attached to those amino acids already exist, right? And then this one shifts, go here, and then leave, exit. I hope I'm making some sense. I hope animation will show it.
Is that step 1 and step 2? How does that?
Step 1, step 2, what are your steps? Tell me your steps and I'll
If you go
go.
back just a couple slides, just a couple. One more. No.
This one
Oh, yeah,
first
that one.
and second?
Yeah.
Okay, a correct match between tRNA and amino acids, that was This is step one. The correct match between tRNA, the enzyme, tRNA, and amino acids. There has to be a correct match because these three AUA matches with tyrosine. Okay, that's the first step. If you're looking for that one, and then second one, they go to ribosomes, anticodon, and then the second match. This would be your second step. The anticodon matches with codon. That would be the second step. Okay, first step was, I see what you were saying now. First, that's the first step. This slide is first step, and this slide is second step. Okay? Please stop. Okay, so let's move, all of these we already talked about it. The ribosome, P side, holds the tRNA that carries the growing polypeptide chain. A side holds the tRNA that carries the next amino acids and add to the chain. And E side is the exit where we already talked about all of that. I talked about all of this.
Oh, okay, so those sites are important.
Yeah. EPA, exit sites, peptidyl tRNA binding sites, and A sites, the amino acid sites. Yes.
So we'll start at A, then go to P, then go to E.
That's right. Very good. E is the exit. Okay. Now, and E side. Okay. Building a polypeptide. The three stages of translation is initiation, elongation, termination, just like transcription. Is that right? What were the three stages of transcription? Initiation, elongation, termination. What are the three stages of translation? Same thing. Initiation, elongation, termination. What is being elongated here? Amino acids. Amino acids are being attached together to form a polypeptide. Termination, at the end, you have the stop codon says it's over, finished. The amino acid sequence stops. All three stages require protein factors that aid in translation process. Energy is required for some of the steps. Right here, let's go over it. A GTP is needed for combining the anticodon to codon. Right here is a P side, right here, and then the elongation, the polypeptide change. During elongation, amino acids are added to one end by C terminus. You guys remember C terminus of the growing chain? You remember that? What is C terminus? From exam number 1 material. That is the acid end of the amino acid. C terminus and N terminus. I said that during the exam number 1 material. So C terminus is where the acid group of amino acid is. That's called C terminus.
What was the other end?
C terminus of the amino acids.
You said there was another end. C terminus
and N terminus. N is amino. It's an amino end. N terminus. It means the amino end. Amino acids, if you would, they have a C terminus and N terminus. If you want, you can look at it at the beginning. Each addition involves proteins called elongation factors and occurs in 3 steps: codon recognition, peptide bond formation, and translocation. These two, they need energy. Out of these 3 steps of involving protein elongation, codon recognition, and translocation need ATP. Energy expenditure occurs in the first and third one. Translation proceeds along the mRNA in a 5' to 3' end. Right here, GTP is needed. That's the first step. Second step does not need GTP, and the third step needs GTP. Okay, so these respond to the last slide. Termination of translation. Termination occurs on stop codon in the mRNA, reaches the A side of the ribosomes. The A side accepts a protein called a release factor. The release factor causes the co-addition of water at the end. a molecule instead of amino acids, the reaction releases the polypeptide and translation assembly comes apart. Right here, again talking about the stop codon is 3 of them, UAG, UAA. You don't have to memorize these. I don't expect you to know the stop codon. It is important that you recognize them. These are the 3 codons that tells it's over. And of course water is a 3 amino acids, and of course everything comes apart. The mRNA, the release factor, and then the ribosomes, they all come apart. Completing the targeting functional proteins, often translation is not sufficient to make a functional proteins. Polypeptide chains are modified, and I will talk about that next time. Let's talk about this next time. That's 9:30. I better stop right now. We'll finish chapter 17. It is in DocuShare on the first page. I put it in the wrong place. I'm sorry about that. But it is in DocuShare, and then